Hello, and what I'm going to try to do is a relatively quick video, which almost never ends up being relatively quick. This is a M&M lab that I'm going to be running in my geology classes, physical geology class, and I'm going to be out of town for the next 3 days, so this is what's going to happen, I hope, on Wednesday. Um, so what I want to do is I want to show a little bit about what you're going to be doing, and if you take a look, we need a cup, 100 M&Ms, which I hope is 100. You need a paper towel and graph paper. For graph paper, I'll try to provide if I can remember to print some out. Procedure, make a rough draft of all 4 tables. You can see you make a rough draft of this table. Don't have to worry about filling in this information. I'll explain that in a second. Fill out this one. This is class data. This is individual data. This will be just for your group. This will be just for the class, as well as if you're in third period, this will be for 6th period. 6th period and 3rd period together. 3rd period data I should have already, and 6th period will just add it to theirs, and 3rd period will get it the next day. Here's one here for theoretical data. Individual group, what did you get on the runs, class runs, and then theoretical value where we take 100 and we should end up with 50, 25, 12 and a half, keeps going down, 6 and a quarter keeps going down by half all the way down. And then assigning dates to it with carbon dating, where if we start off with 100, that represents 0 years, and if we end up with 50, that's going to be 5,730 years later. End up with 25, that's an additional 5,720 or 11,460. But for this project, you're going to take the M&Ms that are in a cup and you're going to pour them out on a paper towel because I wouldn't trust that table. You're going to actually make sure that all of them have an M side, so make sure that you flip them all over. You can see some facsimile of an M just to differentiate the one side from the other. Dispose of any that have no M's, and I'll have the subs have some extra M&Ms to give to you. You've got to end up with 100, so if you get 108 in there, you can dispose of those 8 any way you want to. And I'd like you to write that number in your rough draft, so enter your top number there, which is going to be 100. Then make a prediction of how many candies or how many radioactive parents you're going to have left after the first toss. And normally we would say like 50. And then count out each of the 100, put those in the rough draft, make a prediction of how many pieces you're going to have, toss them, write that number of prediction of the toss, record it in the trial 1, place the candies in the cup, shake them carefully, dump them out, move them one side to the other. M side is the one you're going to keep. Dispose the rest any way you want to. Count and record your data table. Count the number of pieces. Put those in your trial 1. How many you're going to have left after the next time you try it. And just repeat those procedure numbers 2 through 7 until you have no radioactive, and basically you have no M&Ms left. Pool the class data. I'm going to have an Excel sheet which looks like this. Sorry. It's going to look like this, and you can see this is 3rd periods, and I'm going to go ahead and go in here and take all this data, and I'm going to clear it because I'm going to have table 1 put their data here, however many trials they have, and I have 6 trials added into here. Table 2, Table 3, Table 4, Table 5, or whatever lab number you get for these. And what will happen is if you put it in here, let's say put 50, and you go down, and you can see our total is 50. The average is 4.5. I'll have to actually change this number from 11 to however many groups we have, and I'll do that once we get back. But basically what should happen is even if these don't work out to a half-life, when we start averaging these together, it should get closer and closer to the average 50, and it should work when we actually put 5th periods whose data is here, and I'm going to take out all that data. And you can see some of them actually go all the way to 11 groups, and you're going until you get to 0. Some finished, 2 groups finished up with very few tosses. I got a couple more finishing up there, 1 finishing there, a couple few there, 2 more, 3 more there, and 1 group actually went to there, to the 11th trial. And if I go back, let's see, looks like we had 5 groups make it all the way to the 10th. So if we go back to the Word document, they used this. 1 group had to do some more, so I had to add another row to that table. Here, trials, we'll have to add more if we actually get some that go more, but basically we'll have class data for tables 1 through 10 or whatever. And then finally calculate the theoretical half-life for all the runs in the graph. So you put the individual groups there, your group, and we're going to put the class average for 6th period there, and we're going to put theoretical values there, and we're going to do the same thing here where we actually can figure out some things next class, figure out the age of a couple of different scenarios. And then we're going to actually put those on a graph, and we're going to color and label the 3 lines, but we can do those next class as well. Okay, so that graph, that lab, and let me actually show you one example. If we go into here and we take a look at this, this is 500 atoms of radioactive polonium. This is a fictitious atom, but basically we have 500 atoms in here, and what we're going to do is we're going to graph it. It has a half-life of 2 seconds, and right now we have 500 remaining. So if I push play, you can see the number of radioactive parents are changing into something that's stable, and I'm not sure what it is because it doesn't really remind us, but we've got 13, 12, 8, 7, 5 remaining. Of that 500, if we go down to how many right there where we have half of those left, that would have been 250, and you notice that's about 2 seconds, which they're saying is the 2-second half-life. How much time does it take to get half of what you've got initially remaining? And then here we have 250. It takes another 2 seconds to get it down to 125, and then another 2 seconds to make it half of that, and another 2 seconds to make it half of that, and half of that, and half of that. And essentially it keeps going down and down and down, and it will eventually leave, even though it may take a long time. If you take a look at the blue line is the theoretical, and it actually crosses perfectly at all those points, and the black line are the number of dots that ran in this experiment. So you may not get a perfectly 50% at each half-life, but if you kept running this over and over and over and over again, or we have enough groups in the class, or we have enough groups in the 2 classes, or if we ran this with other teachers in earth science classes, which they run this as well, we would come up with a 50 average. Okay, well, thank you very much for getting this, and I hope you understand some questions. Ask the sub. Hopefully they'll be able to tell you as well. All right, take care, and we'll see you next week. Bye.